Good morning, friends. Today we will cover the third lecture on Sf4 Molecule. In the last class, we were discussing about the sp3d hybridization. If the hybridization will be sp3d, then the geometry will be TBP, trigonal bipyramidal. It will be trigonal bipyramidal. Geometry will be trigonal bipyramidal. This is possible when all the bonds are sigma bonds. That means the central atom is surrounded by 5 number of atoms which make sigma bond with the central atom. But whenever apart from the sigma bond some lone pairs will be present, then the shape will be different. Now here we will discuss about the Sf4 molecule. You know the electronic configuration of sulfur. This is 3s2 3p4. So in its outermost orbit there are 6 electrons to participate in the bond formation, but here there are 4 peripheral atoms, so only 4 bonds will be formed. Only 4 bonds will be formed and one lone pair will be there over sulfur. So now how will draw the shape of this molecule? What is the actual shape of this molecule? It will be, whether it will be look like trigonal bipyramidal. Let's see. In the bend rule, we know in the case of sp3d hybridizations, we apply the Bend's rule. What does it say? It say the electron pairs, lone pairs always prefer to stay in the equatorial position. Lone pair always prefers to stay in the equatorial position. So here we have to arrange 1, 2, 3, 4 bond pair and 1 lone pair. So in an effort to do the trigonal bipyramidal geometry, what we will do, we will place sulfur here and 1 lone pair I will place here and 1 fluorine here and 1 fluorine here, and the rest 2 fluorine I will put in the axial position. Now you see the shape of the molecule will be seesaw. If we will do in other way, for instance, if we will think like that, if all the atoms will put in this way and 1 fluorine in this way and 1 lone pair below the plane. Suppose Sf3, this is the plane, 1 fluorine above the plane and lone pair below the plane. Then this is against the Bend's rule. Also, if we see, suppose this is the our plane and this is the lone pair. Now we see, we know from the VSCPR theory, lone pair repulsion is greater than lone pair bond pair, and lone pair bond pair repulsion is greater than bond pair. So here lone pair bond pair and bond pair repulsions are there. 2 types of repulsion. One is lone pair bond pair, other is bond pair. Here the bond pairs are 120 degree apart. So there are minimum repulsion there, but this lone pair makes 390 degree angle one with this fluorine, one with this fluorine, one with this fluorine. Suppose you think lone pair is above here. So this is one fluorine, this fluorine to this fluorine 90 degree, this fluorine to this fluorine 90 degree, this fluorine 90 degree. So due to this lone pair, it makes 390 degree angle with this fluorine atom. So it will face 390 degree 90 degree repulsion, 390 degree repulsion between lone pair and bond pair. But here if you will draw the trigonal plane, you see this is the lone pair in the plane and one fluorine atom in the axial position, other in the axial position. So this fluorine makes 90 degree angle with this lone pair and this fluorine makes 90 degree angle with this lone pair. So here we are getting 290 degree repulsion between lone pair and bond pair. So obviously here we are facing 390 degree repulsion between lone pair bond pair, and here we are facing 290 degree repulsion between lone pair bond pair. So here repulsion is more, so it is less stable, here repulsion is less, so this is more stable. So this is the accepted shape of this molecule, which is seesaw, but this structure is totally wrong. This structure is totally wrong. This is not accepted. If we will discuss about the ClF3 molecule, ClF3. Now here chlorine is the central atom here. Its electronic configuration is 3s2 3p5. That means 7 outermost electrons in its outermost orbit to do the bond formation. But it has 3 peripheral atoms, so it can only make 3 bonds. Other will be remain as the lone pair. So there are 2 lone pair and 3 bonds. So obviously the geometry should be trigonal bipyramidal, but due to its presence of lone pair over chlorine, its shape will be changed. How the shape will be? How will arrange? Now if we will apply the Bend's rule, what we will do? First we will do write the chlorine atom in the plane, and we so in the plane what we will do, it will be trigonal plane. We will put 1 fluorine and 2 lone pair in a single plane. Okay, so this is our plane now, trigonal plane, and rest 2 fluorine atom I will keep in the axial position. So if we will forget about the lone pair, how the shape is looking like? Cl, F, F and F. So the shape is just like T shape. What we call it? T shape. So the shape will be T shape. ClF3, the shape will be T shape. One more molecule, XCF2, xenon difluoride. Xenon is a 0 group element, we know. So it has 8 outermost electrons in its orbit. So what will be the shape? Xenon. Here 2 fluorine atoms, peripheral atoms. Apart from this, it has 6 electron, remains 3 lone pair. So obviously we will put the lone pair in the trigonal plane, and 2 fluorine atom we will put in the axial position. So if we will forget about this XCF2, so the shape will be linear. Now we will switch over to the octahedral part. If the hybridization will be sp3d2 sp3d2 3 4 5 6. Then the geometry will be octahedral. Now the geometry will be octahedral. For instance, Sf6 molecule, here the outermost electron configuration is 3s2 3p4, 6 outermost electron to participate in the bond formation. So what we will do, we will put 4 fluorine atom in the equatorial plane and 2 fluorine atom in the axial position. So it's look like octahedral. It looks like octahedral. So the geometry will be octahedral. This is called octahedral geometry in case of Sf6 molecule. Now if we discuss about the Br(F5), now here bromine is the central atom and it has 7 outermost electron. So what we will do, we will put 4 fluorine atom in the equatorial position and 1 fluorine atom in the axial position and 1 below the plane. So the shape will be square pyramidal. The shape will be square pyramidal, because here all the fluorines, 4 fluorines in the one plane, above in the axial position 1 more fluorine, the shape will be square pyramidal. The rest is the XeO(F4). Here also xenon 0 group element is a 8 outermost electrons. So we will put the xenon in the central part and 4 fluorine in the square plane and 1 O in the axial position and 1 lone pair below the plane. So this is the XeO4. Now if we will discuss about the xenon tetrafluoride. Similarly, xenon has 8 outermost electrons. So here 4 fluorine will be in the plane and 2 lone pair above the plane and other will be below the plane. Okay. So one more small things, one more is pending, which is called sp3d3. Its shape will be pentagonal bipyramidal. So for here we will discuss the example IF7. Iodine has 7 outermost electrons. So what we will do, first we will draw one pentagon. In the center we will put iodine. So 5 fluorine atoms in the plane and 6 fluorine atom above the plane and 7th fluorine atom also below the plane. So if we will draw, it is look like pentagonal bipyramidal. It is look like pentagonal bipyramidal. So that's all about the shape of the molecules. So to know the complete idea about the shape of the molecules, we have uploaded 3 videos: shape of the molecules part 1, shape of the molecules part 2 and shape of the molecule part 3. I hope by following all the 3 videos you will have the complete knowledge and concrete idea about the shape of the molecule. That's all. Goodbye.